Let us consider a notion of the center of gravity of a rigid body. To do that, let us consider a system of parallel forces of gravity of particles of the rigid body. This system of parallel forces is determined by the center of parallel forces, the point C, and it is this point that is the center of gravity of the rigid body. The location of the center of gravity is determined with its radius vector. And we write down the equation via the values of the weights of elementary particles and radius vectors determining their positions. For uniform bodies, the center of gravity is defined with their geometry. In particular, the center of gravity of a uniform volume, if we were to consider a specific weight, will be written down via elementary volumes of the particles of the rigid body. And then, when considering the corresponding integral sums passing the limit at an elementary volume approaching zero, we obtain that the coordinates of the center of gravity are determined with trivariate integration over the volume. The center of gravity of a homogeneous surface. When considering elementary surfaces and their corresponding weights, let us introduce a center of gravity of a homogeneous surface. In this case, the coordinates of the center of gravity are determined by the surface integrals at a limiting passage as an elementary area is approaching zero. In the case of homogeneous line, by dividing this line into elementary particles, the center of gravity of the homogeneous line is to be determined by curvilinear integrals over the line.